in the bag.
Okay. Last class, people, we started with Daniel's cell. We started with Daniel's cell. Then we did different types of half cells or different types of electrodes. Which were the 4 types of electrodes that we did?
Metal ion electrodes, gas ion electrodes, very soluble electrodes.
And redox. I repeat, metal dipped in metal ion, gas ion electrode, sparingly soluble salt with common anion wala electrode, and the last one was redox electrode. Now, let's continue with the chapter. The next part of the chapter, people, is called as electrode potential. So let's understand what do you mean by electrode potential. Now, we go back to the same setup. The first electrode that we had learned. What was the first electrode, people? Metal in metal ion electrode. What was metal in metal ion electrode? हमारे पास है एक metal rod which is dipped in its own ions. Solution containing its own ions. ठीक है? So, for example, we had taken zinc rod which was dipped in ZnSO4 solution. So, इसको people we had said that this is M and the solution contains its ions. इसको हमने बोला था people M metal and यहाँ पे क्या था people Mn plus. बराबर? Now, this can behave like cathode, but this can also behave like anode. Yes or no? एक सेकंड पॉज करना. Okay. Now, so when this behaves as a cathode, what will the reaction be? It will be reduction. And क्या process होगा? Electrons, the ions which are present in the solution will accept electrons and they are deposited on the rod. क्या मिलता है यहाँ पे? What is the equation that we wrote? Mn plus Ne minus. This becomes M solid. How did we write इसका representation? M N plus equals. What does a single line represent? Change in phase. और यहाँ पे क्या बन गया people? M solid. ठीक है? Also, इसके बाद में हमने कुछ ऐसा लिखा था that eventually what happens is what is left in the solution is only negative ions. Remember SO4 2 minus ions? Since all the M plus ions are deposited on the rod, there is this charge developed. Yes or no? So the potential difference over here, or the potential developed due to what process? Reduction. That electrode potential is termed as reduction potential. If this is happening in standard conditions, then we call it as standard reduction potential, also abbreviated as SRP. So whenever there is any electrode which undergoes reduction, the potential which is developed, the potential difference जो यहाँ पे develop होता है because of reduction, हम उसको क्या बोलेंगे? Did you people get that? बोलो रे. And that potential developed, उसको हम उसके cell representation में we can also show it something like this. E naught, which is standard potential, M n plus aqueous single slash M solid. This is the potential developed due to what? SRP, standard reduction potential. Now let's do this for oxidation. What happens in case of oxidation? The atoms from the rod come into the solution in the form of Mn plus, leaving behind what? तो यहाँ पे हम क्या लिखते थे? That now what is present on the rod? Negative charge. Electrons are present on the rod. And solution क्या बन गई? The solution is highly positive. Again there is a potential difference. What will the reaction be? This is behaving like an anode. Anode pe what do we say is happening? Oxidation. Yes or no? What will the reaction look like? The same ulta. So M solid giving Mn plus aqueous plus Ne minus. How will you write the cell representation? As M solid single slash M N plus aqueous. Bolo yes or no? And this potential will be called as standard oxidation potential. Anyone who did not get that? Or also called as SOP representation. You can write the same thing as E naught, this, which is nothing but E naught standard oxidation. Any questions still here? In order to make a cell, you should have a cathode. You should also have a anode, which means एक electrode पे oxidation होगा, एक electrode पे reduction होगा. And hence, you can use these potentials to find, I repeat, you can use this to find standard cell potential. Which is represented as E naught cell. The potential of any cell is given as the standard reduction potential of cathode, E naught SRP of cathode, minus the standard reduction potential of the anode. Standard reduction potential. Now, what can be the relation between SOP and SRP? Can I write E naught SRP is equal to minus E naught SOP? And hence you can also modify this formula. Instead of E naught cathode, SRP of cathode minus E naught SRP, both SRP, I can write the same formula in terms of SOP as E naught anode, but now the SOP of anode minus E naught the SOP of cathode. एक और फॉर्मूला बना सकते हैं हम, which is E naught SRP of cathode plus E naught SOP P of the anyone who did not get that? Chalo. Coming back. So what is, these are the three formulas, people. E naught cathode, E naught anode. If I have both the SRP values, अगर दोनों SOP है तो formula will change to E naught anode SOP minus E naught cathode का SOP, and if one SRP and one SOP given. Next, छोटा सा एक नोट लिखते हैं और for cathode will always have higher SRP. तो जिसकी भी SRP ज़्यादा है will always behave like, or it will have SOP. So दो इलेक्ट्रोड दिए हैं. The electrode जिसकी SRP ज़्यादा है will always be the cathode, and जिसकी SRP कम है will be your, so higher SRP, lower SRP will behave like anode, and or higher SOP. Did you people get that? Yes or no? So a new page, please write down electrode potential. We'll first write the theory for the same. When a strip of metal, is brought in contact, when a strip of metal is brought in contact when a strip of metal is brought in contact with solution containing its own ions, with a solution containing its own ions, then the strip of metal gets positively or negatively charged. A strip of metal gets positively or negatively charged and results into a potential being developed. Between the strip and its solution. Between the strip and its solution. This potential is known as electrode potential. Next point, the potential developed during oxidation is known as oxidation potential, and during reduction is known as reduction potential. The potential developed during oxidation is known as oxidation potential, and during reduction is known as reduction potential. The value of electrode potential, next point, the value of electrode potential depends on first nature of the electrode, nature of the electrode, second, concentration of solution, and third, temperature. Temperature. Next point. At unity concentration, at unity concentration and 298 Kelvin, unity concentration 298 Kelvin, 1 atmospheric pressure, 298 Kelvin, 1 atm pressure, the potential of the electrode is known as, the potential of the electrode is known as the potential of the electrode is known as standard electrode potential. Standard electrode potential. Note. The given value of electrode potential. Note. The given value of electrode potential. The given value of electrode potential is regarded as reduction potential unless is regarded as electrode potential, reduction potential unless specifically mentioned. Next point. Yes, same. Next point. Not part of note, but next point. अभी note खत्म हो गया था. Next point. Electrons flow from anode to cathode in external circuit. Electrons flow from anode to cathode in external circuit. Due to pushing effect. And this is known as cell potential. And this is known as cell potential or electromotive force of the cell. The expression for cell potential under standard conditions. The expression for cell potential under standard condition is given by the expression standard condition. The formula is on the board, people, and ये भी copy कर लो. ठीक है, what exactly is SOP, SRP, and what's the relation between SRP and SOP, and then we continue with numericals. Okay. Now we continue with numericals based on cell potential. Let's read the first question. For the following cell representations, give the reaction at cathode, reaction at anode, overall reaction, and calculate standard cell potential. Now, people, this is our first cell representation. Tell me in this cell representation which part is cathode and which part is anode. Excellent. First is anode, and this part is
cathode.
cathode. What happens at the anode? Oxidation. So, क्या reaction होगा at the anode? Cr becomes Cr3 plus and releases how many electrons, people? 3 electrons. Now, what happens at the cathode? Reduction. Carefully observe what the reduction reaction will be. I2 becoming, sorry, it is reduction, so it has to gain electrons. So this is going to become I minus. Yes or no? But this is 2, so I would need how many electrons here? So this will become 2I minus. With me till here? Yes or no? Now, please observe this. How many electrons were lost at the anode? How many were gained at the cathode?
2.
So we need to balance this. Electrons lost should be equal to the electrons gained. तो कैसे करेंगे यहाँ पे? How will you balance this out, people? You will multiply the anodic equation by 2 and cathodic equation को आप किससे multiply करोगे? 3 से. So क्या equation मिलता है यहाँ पे? 2Cr solid gives 2Cr3 plus 6 electrons. And what will this equation become? 3I2 plus 6 electrons gives 6I minus. And now we write the overall equation. How do you write the overall equation? LHS और RHS बस add करना है. So what will the overall equation look like? 2Cr plus 3I2 becomes 2Cr3 plus 6I minus. Did you people get that? But we also have to find something. We have to find cell potential. What is the formula for cell potential? E naught cathode. Now which is cathode and which is anode over here? So this is E naught cathode minus E naught anode. This will give me cell potential. When I look at this, tell me people, have they given us the SRP or have they given us SOP? Excellent. तो ये हमारे पास SRP है. यहाँ पे भी हमारे पास SRP है. Chromium is anode, iodine is cathode. तो कैसे हो जाएगा वो? 0.54 minus 0.74. So कितना हो गया? 4 plus 4, 8, 1.28 volts. Anyone who did not get that? Okay, I'll clear this and we'll now discuss the second question. Now we will look at the second question. What do we have here? LHS is a metal ion electrode. But what about the RHS? कौन सा टाइप का इलेक्ट्रोड है वो? Very nice. Metal insoluble, sparingly soluble electrode. चलो. Again, same thing again. Left में क्या होता है people? We have the anode And right now, what do we have? Cathode. Can someone give me the reaction? What will happen at the anode? CD becoming CD2 plus releasing 2 electrons. This is what's happening at the anode. Cathode का reaction क्या होगा? Anyone? AgCl plus electron becomes Ag plus Cl minus. How many electrons did cadmium lose? तो यहाँ पे भी कितना होना चाहिए people? So we'll multiply this by 2. Can you tell me what the overall reaction will look like? CD plus 2 AgCl becoming CD2 plus 2Ag plus 2Cl minus. Yes or no? Now carefully observe the potentials given. I repeat, carefully observe this and look at cadmium. What is this value given? Excellent. So for the anode, they have given us the, and for the cathode, they have given us the SRP. So which formula will we use here? E naught cell is E naught
Cathode
the
SRP
SRP of the cathode
plus SOP of
plus E naught the,
SOP of the anode.
since the SOP is given, the SOP of the anode. So how much is that? 0.22 plus 0.4. So the answer is 0.62 volts. Okay, so people solve this as a homework question where you have to find cell potential, but I would say ki pura cell representation, right, the anode cathode reaction, do everything. Okay, now let's continue. The next topic that we have is relation between free energy or Gibbs free energy and cell potential. Anyone remembers what was Gibbs free energy? We did this in thermodynamics. Excellent. It is the amount of work obtained in reversible processes. And for spontaneity, what should be delta G? Delta G should always be less than 0 for spontaneous processes. Now we can use the same concept, but here the work done will be electrical work. Now I think physics में हमने किया है, electrical work will be charge into potential. People किया है ये in physics. Electrical work is charge times potential. Now let's say I have cell whose standard potential is E naught, so I call it E naught cell, and the charge derived from the cell is given as N into F. I'll explain what that means. F here stands for Faraday. What exactly is Faraday or 1 farad is? It is the charge on 1 mole of electrons. So you can calculate the charge on 1 mole. What is the charge on 1 electron? 1.6 into 10 raised to minus 19 coulombs. And how many electrons are present in 1 mole? Excellent. Avogadro's number.
Into 10 raised to minus 10 raised to 5.
When you multiply this, you get approximately 96,500 coulombs. It is something 96,485 point something, which we round it off to 96,500 coulomb. That is the meaning of 1 Faraday or 1 farad. N is nothing but the number of moles of electrons participating in that cell. Now, this work, since we're talking about Gibbs free energy, so we can replace this by delta G. Standard is the delta G naught. And remember, the value of delta G should decrease for any process to become spontaneous. So the formula becomes delta G naught is minus NF E naught cell. This gives us the relation between delta G and E naught cell. This is standard condition. If it is non-standard condition, you can write the formula as delta G is equal to minus NF E cell. Any questions here? Chalo. Now, we also had one more formula in equilibrium. Anyone remembers what was the relation between delta G naught and K? Delta G is delta G naught plus RT ln of Q. What does Q stand for? Q over here is reaction quotient. Let's say we have a reaction something like this, AA plus B in equilibrium with CC plus D. How will I write, people, the expression for reaction quotient? Q is equal to concentration of C raised to C into over A raised to A into B raised to B. Yes or no? So I can write the same expression over here. So delta G is equal to delta G naught plus RT ln of, I can write C raised to C into D raised to D upon A raised to A into B raised to B. Anyone who don't get that? Now what is the expression for delta G? Minus NF E cell is equal to, what is the expression for delta G naught? Minus NF E naught cell plus, if I want to convert ln to base 10, 2.303 RT log of C raised to C into D raised to D over A raised to A into B raised to B. With me till here? Do you see something common? If I divide throughout by NF, so what will I get? Minus E cell is equal to minus E naught cell plus 2.303 RT over NF log of C raised to C times T raised to D over the same thing again. With me? So what does the equation become finally? E cell is equal to E naught cell minus 2.303 RT over NF log of C raised to C into D raised to D upon A raised to A into B raised to B. This equation is known as Nernst equation. We use Nernst equation to find the EMF of a cell under non-standard conditions. With me? Okay. Now we have slight modifications. Pay attention. We know that what is the value of R? 8.314 joule per Kelvin per mole. Let's say if the temperature is 298 Kelvin, we know the value of F. How much is the value of F, people? 96,500 coulombs. And if we substitute all the values here, 2.303 RT over F becomes approximately 0.05916. So you can modify the formula as E cell is equal to E naught cell minus 0.05916 over N. बाकी सब substitute किया ना, we substituted R, we substituted log of C raised to C, D raised to D is the product side, A raised to A, B raised to B is.
Reactant side.
Now, you can also write this as products over,
Reactants.
there's more to it, pay attention. These will have only gases or gaseous ions. Because the molarity of solids doesn't really change. हमने इसको equilibrium में भी पढ़ा है. We apply the same thing. Or there's one more way of writing. Instead of products, when we do sums, तब ये थोड़ा और clarity आएगा. Oxidation, or the elements which have undergone oxidation to the ones which have undergone reduction. I repeat, when we do sums, this becomes more clear. So the different variations of writing Nernst equation. So next class, we will start first by doing numericals on Nernst, on delta G and on E naught, E cell and E naught cell. Okay? Copy this and we continue next class.